Okay, a few quick definitions. AN increases. We mean the outputs get higher. The outputs get higher. That means A1 is less than A2, is less than A3, so on and so forth. Right? In other words, in one notation, you could say AK is less than A subscript K is less than A subscript K plus 1. Right? You plug in bigger inputs, you get bigger numbers. That's what we're saying. If AN increases. Switch that inequality around if AN decreases. AN decreases if A1 is bigger than A2, which is bigger than A3, which is bigger than A4. So you switch this inequality around and you could say, oh, AK is bigger than AK plus 1. It's monotonic if it either increases or decreases, but not both. So if you graph the points that represent the outputs of the sequence, it either goes up or it goes down, but not both. That's what monotonic means. Monotonic, monotonic, tomato, tomato. Okay, how could we show that Bn equals 2n divided by 1 plus n is increasing? How'd you do it in Calc 1? You remember? If the derivative is positive, then the function's increasing, right? If the derivative is negative, the function's decreasing. We have to use the related function here. So we look at the related function. The related function, just use f of x. So use an input of x instead of n. Take the derivative, show that it's positive. And then we know from Calc 1 that the function is increasing. Well, there's no reason why the related sequence wouldn't be increasing if that's true. So what rule do you have to use here to take the derivative? Okay, f prime of x is equal to low d high minus high d low over low squared, right? Low d high minus high d low over low squared. Okay, so what's the lower function? 1 plus x, low d high. What's the derivative of the higher function? 2. 2x is the higher function, derivative is 2. Minus high, 2x, d low. What's the derivative of the lower function? Derivative of 1 plus x is 1. Does everybody see where that numerator comes from? Quotient rule. All over low squared, which is 1 plus x squared. Does that look familiar to you? Okay, what do I get in the numerator when I simplify? So this is really 2 plus 2x here. That's a minus 2x there. So what do I get in that numerator? Just 2. Now what's x allowed to go from? Since n starts at 1, x is going to start in the same spot. So can you say 2 over 1 plus x squared is positive for x greater than or equal to 1? Actually, it's always positive, right? It's greater than 0, means it's positive for x greater than or equal to 1. Well, it's true for all x, but we only need it to be true for x is greater than or equal to 1. So what's your conclusion? So f is increasing. Well, if f is increasing for all x greater than or equal to 1, then Bn is also. So f is increasing for x greater than or equal to 1, which means Bn increases for n greater than or equal to 1. Which means Bn increases for n greater than or equal to 1. And that's all you needed in that one. We'll show you why it's important to know whether a function increases or decreases later on. But that's a skill you need for later on. Every bounded monotonic sequence converges. Why? Well, let's say AN converges to L. And so if M is an upper bound for AN, then L could be M or it could be below it. So let's say that line represents L. But if AN is monotonic, let's say it only increases. It could mean it only decreases. But then if if it only increases, it doesn't have to increase in a straight line, but if it only increases, it has nowhere to go but up towards L the way I'm drawing it. Or if it decreases, it would have nowhere to go except, and it's bounded below, then it would have nowhere to go. It would have to approach that limit, whatever it happens to be. So that can come in handy if you know that you have a monotonic sequence that's bounded. In this case, it has to be bounded from above because it's increasing. Guaranteed, it's gonna approach a limit. And hopefully that's intuitively true, because that's as far as we're going to go. We're not going to try a proof of that here.